All right, now we want to look at some integration examples. The first one we have here is we're looking at the integral of the square root of x plus 1 over 2 times the square root of x. And if you recall before, we do not have a quotient rule, so the first step is to rewrite the integral into a form that we can integrate. So we can write this as the integral of the square root of x. If it's easier, you can think of that as x to the 1/2 power plus, and if we move this up to the top, this x becomes to the 1/2, but because we move it to the top, it becomes a negative 1/2, and we'll keep the 2 on the bottom. So now we have a very easy form to integrate, and if we integrate this, we take x to the 1/2, we increase the exponent by 1, so that will become x to the 3/2. And at this point, we can divide by the 3/2. Now, to make it easier here, you're going to have x to the 3/2 over 3/2. Then the easiest thing to do is go ahead and multiply by the reciprocal. If we're going to divide by 3/2, that's the same thing as multiplying by 2/3. All right, then we have x to the negative 1/2. So if we increase that by 1, that would become x to the positive 1/2. Okay, and then once again here, we would divide by 1/2, but if we multiply by the reciprocal, then we're simply going to multiply by 2. And keep in mind, we already have this 2 in the denominator, so there's already a 2 there. And then, of course, we have plus our constant c. So we can simplify this. We have 2/3 x to the 3/2. And, of course, the 2's cancel, and you're left with x to the 1/2 plus c. And at this point, if you want to, you can rewrite the 3/2 or the 1/2 back into the square root, but you could just simply leave it as fractional forms for the exponents. All right, the next example. Once again, we have here the integral of the 4th root of x cubed plus 1. And again, if you feel like it, maybe you can pause the video and see if you can work this out on your own first before I show you the steps. So the first step is we want to rewrite the problem again, and we can think of the 4th root of x cubed as x to the 3/4 power plus 1. And then if we integrate this, we would take your x, the 3/4, we would add 1. So therefore, we would end up with 7/4. And once again, we're going to divide by 7/4, which means you would multiply by the reciprocal, which would be 4 over 7. So we would get 4/7. And what about the plus 1? Well, if we have plus 1, there's a constant, so we simply increase the x, so that would be simply x. And another way to think of this plus 1, you could think of this when you're integrating 1 dx. You could think of this as 1 x to the 0. And x to the 0 we know is 1, because anything raised to the 0 power, of course, we know that's going to be equal to 1. Well, if you think of your rules here, we're going to increase the exponent by 1. So if we increase the exponent by 1, we're going to get x to the 1st divided by 1, which is simply x. So if you ever forget how to handle a constant, just realize it's understood that we have this x to the 0 there. So here, we can think of this as 1 times x to the 0, and if you increase the exponent by 1, you get x to the 1st divided by 1, or simply x. And as always, we want to add our constant term. All right, this next example, x squared plus 2x minus 3 over x to the 4th. How can we integrate this? Do we have a quotient rule? And remember, that is only true for differentiation. So once again, how can we rewrite this into a form that we can integrate? And the first step, because all of this is over x to the fourth, we could actually divide this up into three fractions. Whereas x to the fourth is our common denominator, we could rewrite this as simply x squared over x to the fourth plus 2x over x to the fourth minus 3 over x to the fourth. And then we can simply reduce. And if we simplify this, we would end up with x squared over x to the fourth, which would be 2 minus 4, so that's x to the negative 2, plus 2, again here we have x to the first, so 1 minus 4 would be x to the negative 3, minus, and there's no x on top, so we have 3, and we can just simply think of moving the x to the top, so that makes it x to the negative 4. And at this point, we have a nice form that we can integrate. So x to the negative 2, now be careful. You have negative exponents, so when we increase the exponent by 1, we're going to get x to the negative 1 divided by negative 1 plus 2x. Negative 3 plus 1 is a negative 2 divided by negative 2 minus 3x to the negative fourth. So if we increase that by 1, we get a negative 3 divided by negative 3 plus c. So there's our integral, and if we simplify this, we can take and move the x to the negative 1 to the bottom, and that would simply be x to the first. And of course, then we would need a 1 on top, and the negative sign says we have a negative fraction, so we have negative 1 over x. And then we have the 2's here that will cancel out, and we have a negative, so that's going to make it minus. Move the x to the bottom, so that becomes x to the positive 2. And again, the two negatives here make it a positive. The 3's cancel, so we have 1 over x cubed plus c. Now, in a lot of cases, it doesn't really matter if you leave your exponents as negative exponents. You'll find out the further we go in calculus, the less we're concerned with necessarily having positive exponents. But in this case, I think it makes things to look a lot nicer if we change our exponents to positive and simplify this one. All right, one last example. 1 plus t times t squared. Well, once again here we have a product, but we do not have a product rule. So how can we integrate 1 plus t multiplied by t squared? Well, the first step is we're going to have to distribute the t squared, and we would simply get 1 times t squared is t squared, and t times t squared would be t cubed. And we certainly then have a very simple integral problem. T squared becomes t cubed divided by 3 plus t to the fourth divided by 4. And of course, then we have our plus c.